In this video, I'm going to review this huge 230 amp hour lithium iron phosphate 48 volt server rack battery I recently purchased from Orient Power. This battery has 11.7 kilowatt hours of storage capacity and a 200 amp configurable BMS. I'm going to show you some of its features. I'll do some testing. I'll show you the BMS software where you can configure this battery. Then I'm going to open it up and we'll see what we find inside. Okay, so let me just quickly cover what the battery came with. It came with its inspection sheet, which lists some voltages and different things. It came with an owner's manual, a Cat 5e cable, which is not the cable you connect to the inverter. That's a different cable. These brackets here, I'm assuming, help mount it to a server rack, which I don't have. We have some protective caps. I think it came with 6 M8 studs, and these tin-coated copper brackets, which I'll show you what they are in a minute. Okay, so let's start here with the front of the battery. Let's start with the information here. So it's a lithium iron phosphate. There's a model number. Its rated voltage is 51.2 volts. The rated capacity is 230 amp hours and 11,776 watt hours. That's quite a bit for one battery. Alright, so over here on the left side is a 250 amp breaker. If you turn it on, and if it trips, here's actually a trip test button. It puts it in the middle, so you know that it wasn't turned off. It actually tripped. And this breaker physically disconnects the positive terminals here to the battery inside. And speaking of terminals, so we have 2 positive and 2 negative, and you can parallel 15 of these batteries together for a whopping 176 amp hours of battery storage. That's a lot. Let's see, so we have a power button down here for the BMS, and it actually was on, so now it's on. I turned it off, and here's the screen. Let me show you these little angle brackets I mentioned earlier. They came with the battery. What they're for is, like, see this wire is right in the way of the screen, and maybe you want to offset the wire some. So this appears to be a tin-coated copper bar. So you can mount it here and then put the battery wire over here, leaving a clean view of the screen. So maybe that's something you would use this for. It's a nice feature though that they provided that. And of course I just mentioned the power button here, and so here's the screen. Let me position the camera to get a little bit better view of that. Okay, so here's the BMS screen for the battery here. So what I would have liked to have seen would be, just as soon as you push that button, state of charge. That's like the main thing I think people want to see. But to see the state of charge, you actually see the state of charge, you actually have to hit the menu button twice, enter, down, 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 enter. And that's how you get to the state of charge, which is, I mean, I've seen another YouTuber do it. He had it down pat. He was just like tick, 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 tick until he got right down to it. So that's quite a bit of navigating just to get to the state of charge. But you can find it here, which screen is nice. And in here, I won't go through all this, but you can see temperature. You can go down. Here's the cell voltage. You can go through each cell. Of course, you see all that with your computer. In a minute, I'm gonna go through that and show you that. But you can just go down and see the voltage of each cell, which is nice to be able to do right here without a computer. Let's see, what else can you do? BMS status. Okay, these are like over temperature, over voltage, different protections think that if they're turned on, yes or no. And there's some other things you can do with the screen there. Okay, so getting back to the front of the battery. So we've covered the off the button and the screen. Okay, so here's a, let me zoom in here. So we have an on-off button on the left that's lit up if the battery's on, if you turn the power button on. And then we have the little run indicator there that'll flash if the battery is currently running, and it'll flash if there's an alarm. This will flash red. There's a reset button here for the battery. These are dip switches here that you set for depending upon how many batteries you're running. So the way it's set right now, the first one's in the up position and the other ones are in the down off position. That means that this is either the master battery and an array of batteries that are parallel together, or if it's standalone. So the way I've got it set right now is that the battery is in standalone. You have state of charge indicator there on the bottom to within 25%, so there's 4 indicators. Dry contact if you wanted to start up a generator or something like that. This RS-485 is what you hook to the inverter. That's where that wire runs up behind there and up to the inverter there. So that's what that is for. That wire actually came with the inverter itself. And of course, if you have an inverter that does the CAN protocol, there it is there. There's RS-232 port for connecting to your computer. And I'll be doing that and showing you that. Let me move that wire here. So the RS-485B and RS-485C ports there are for paralleling other batteries together. So that pretty much covers the front of the battery, and there's really nothing else anywhere else on the battery, except it does have some nice handles that to help carry it with. And this thing is very heavy. I had to get my son to help me. I think this battery weighs 185 pounds. I guess that's one downside to getting such a huge battery is it's very heavy, and it's a two-man job to lift this thing. Okay, so now we're going to do a battery capacity test. So first I'm going to explain that. So when I set up the inverter up here to communicate with this battery, I chose a setting and it automatically set the low voltage cutoff, so I can't really change that. It's set at 44, so hopefully that'll get us to rated capacity before it hits 44 and it shuts us off. So I'll zoom in here, but the screen here shows that we have 99.18%. I can't seem to get it charged above that. Even though it's rated at 230 amp hours, it's showing it has a total capacity of 235 and remaining 233. And I'm also going to be using this battery monitor up here. Let me show you this one. And this is bouncing between 100% and 99%. It shows 230 amp hours, sometimes 229. So we'll be watching that as well. I have currently my EV slow charger hooked into here, and I don't got turned on yet. That's what I'll be using to run the test. It'll be around 1100 watts, so it should take somewhere around 10 hours. I'm gonna have to turn off PV input. I'm gonna have to turn off the AC inputs. We're only running on the battery, so I think it's time to get this testing started. Okay, so the test is off and running. I have AC turned off. I have PV input turned off. Let's see what we show here on the inverter. We're totally running off the battery right now. There's no PV input. There's no AC input. We're pulling about 1.39 kilowatts to charge the EV. Let's see what the battery monitor shows. Pull up that window to reduce glare. We're showing around 1527 watts, 228 amp hours remaining. Okay, let's see what the battery's showing. Okay, the battery itself is showing 98.43% remaining with 231 amp hours remaining. So I'll check back whenever this test is complete, see how we did. Okay, so we're approaching the halfway point on the battery capacity test. And I thought this would be a really good time to show you the BMS tools that you can download from their website, load in your laptop, and then monitor the battery, cell voltages, alarms, change settings to work with other inverters, all kinds of things you can do. So before I show you that though, there's a special wire you need. Now you can buy this from their website for around $25, but I think they were out of it and they had to ship it from China, so it was going to take a while, so I just went ahead and built my own. Now they make a video on their YouTube channel that I'll put a link to, all these things in the description, to build the wire yourself. So here, this wire is USB on this end, and the other end is RS-232-DB9 right there. And then I bought this adapter here. It's a RS-232 female adapter, and there's no wire to it. You open up the box and you can put wires exactly on the pins you need to put them in. So this wire coming out of here is an RJ12, and I set the pins according to what the video said, and then you plug that into the RS-232 port right there. Then once you get that set up, you can run the BMS tools and do all the things I mentioned you could do. Here, let me show you what it can do. Okay, so here is their website. If you go to the support center, it's opsolarbattery.com, and you click support center and then download center, you go to this page. And you'll see different things to download here, but the thing you want to monitor the battery right now is this link down here, Orient Power New BMS Tools. So once you click that, it downloads a zip file, and all you do is extract the zip file to a folder. If you go into the folder that you extracted, you'll see this here. Let's click BMS Tools. And we'll And then down here, the first time I opened this was in some other language, so I clicked whatever flag it was showing, and I chose English, then I could read it. So I'm just going to go through this quickly, but I think this is saying we're on pack number 1, which I only have one battery. I can't look at other batteries, but there's no information right now. So you have to go over here and click open, and then that reads. And if you notice down here, it's going to go through and read the information, just continuously cycling through it to keep this updated. So just real quickly here, pack voltage, we have 52 volts, we're pulling 29 amps, state of charge is 59%, state of health is 100%, remaining capacity 139 amp hours, and there's full capacity. This is the number of battery cycles that's going through. Down here's all the different cell voltages. As you can see, a minimum or a max cell voltage, a minimum voltage, the voltage differential across the whole pack for all the cells. Let's see what we got. Temperature over here, which this I think 24 is around 75 degrees Fahrenheit. This is in Celsius. Different alarms, protection statuses, faults, nothing right now. Let's see. Let's go up to the parameters. This would be something you might want to look at. But to see the values, you got to click Read All. And now you can see all the different parameters where you can set the, a cell overvoltage alarms, all kinds of things. Pack, you can over temperature, under voltage, over voltage, all kinds of settings you can set here. And I've not changed any of these, but then you just write them back once you change what you want. Under system config here, this is important. So if you wanted to use a different inverter other than the Orient Power one, this is where you could configure the battery to work with that inverter. So there is, and I don't know if you have to have this password or not, because I didn't need to do it, but it came pre-configured with Pylon, which works with the Orient Power. I had to configure Pylon in Orient Power also. But for the Canon protocol, you can change Victron, GrowWatt. There's different ones down through here. I'm assuming you could have to contact the Orient Power to make sure that your inverter would work. But you can do the Canon protocol, or RS-45 is what I'm using here for my inverter. You see a capacity here. And of course, we saw that on the main page. There's ways to calibrate it, different things. You may need the password for some of these functionalities, though. I think that's about all I want to show you here with these BMS tools. So just what I was worried about, the inverter started flashing a fault, and then it actually shut down and turned off. But we have approximately 18 to 20 amp hours left. So I'm not really sure why, and the battery voltage is actually at 50.5. So why would it shut off? And it's giving me an error code 70. Let me look up and see what that is. Okay, so we're back to running the capacity test. The problem was that, well, it wasn't a problem. It's just that I was able to change the battery type from Pylon in the inverter to user-defined, which allowed the setting to actually go down to 44 volts. I think it must have been set at 50 as low voltage cutoff. So now it's set at 44. So we'll continue with the test. Let's see where we are. We are at a little over 11 amps, about 4% remaining. Okay, so I was able to save the 43 volt low voltage cutoff for the inverter, and look at there, we're down to 0. All right, so the pack is now showing. Let me go ahead and turn. Actually, I'm gonna turn off the charge. I don't want anything to be damaged here. Okay, I turned off the breaker to the EV charger. Now, so what we have here, we have 43.97 and climbing voltage, now up to 44. We do have a pack under voltage alarm, a cell under voltage alarm, and state of charge low voltage alarm. So all those was set. Now the voltage is climbing just slightly since I turned off the EV charger. And if I show you here on the inverter, we have a low battery voltage alarm going off also. So that's a complete pass in my book. We did the 230 hours, and actually there's more left, but I don't want to take a chance in damaging anything, so I'm going to charge this thing back up. Okay, so I just removed the screws around the edge here in the back, and I'm going to take the lid off. Let's see what's inside. Set this out of the way. And what is this? Okay, so we have, looks like it's a diagram of BMS. And there's the part number. I think I saw from another YouTuber that this is a PACE BMS. So we have some more information here. It looks like that's sticky on the back and wasn't sticky enough to stay on the lid, so I'll fix that. All right, I'm going to take the camera off the tripod here so I can move around. Hopefully it's not too shaky. Okay, so the first thing that jumps out to me, which I haven't seen before, is these wire trays here. And that's new, to me anyway. So there's some added protection for the cells. If something was to land on top really heavy, it won't go all the way down to the bus bars of the battery and short something out, because these will help with that quite a bit anyway. Let's see, okay, there's part of the QR code for the cell. I'll try to loosen these screws in a minute, but let's see. We have these bus bars here, which from my understanding are flexible bus bars. You can feel a little indents in there, so they can flex if the cells need to expand. Let's see, all the bolts, they are bolted on bus bars, and they're all torqued and marked. So at a glance you should be able to tell if anything has loosened. What else we got here? There is a nice gap. Of course, we have the handle here all the way around the outside to have a little added space for protection. That's good. Looks like those cells are in there nice and tight, and there does appear to be, let's see if I can catch it here. Let me get the flashlight. There does appear to be material, some kind of material there in between the cells for added protection, which is good. Sorry for the shakiness. Let's see. So, okay, what size wires we have here? We have 4-gauge, 200-degree jacketed silicone wires. We have 2 of those. So that's more than enough amperage coverage for this battery. And we have what appears to be the same for the negative. That's good. Let's see. Oh, there's that 250 amp breaker right there. Let's see if I can get a flashlight in there to see that a little bit better. Whoops. Yeah, 250 degree breaker. And I'll try to use a flashlight to see down in here to the BMS a little bit. Let me spin around. Again, sorry for the shakiness. Alright, so I see some pretty major heat sinks. That's a big BMS. At least to what I'm used to seeing. Okay. I can't think of anything I've missed here. Yeah, this seems like a really good quality, internal build quality. Very tidy wire management all over. These nice wire trays. Seems to be very well protected. Flexible bus bars, big enough wires. I think this is a high quality build. Okay, so I almost forgot to show you the cells. So I was able to remove some screws here and pull this over to the side, and I was able to see a QR code here. And I scanned it with the battery QR code scanner, and it turns out these are Eve cells, which are very good cells. So that even further strengthens my opinion that this is a very high quality internal build. Well, there's not much else I can say about this battery from Orient Power. It is a very good battery. This case is real sturdy. The internal build quality was very good. It had those quality Eve battery cells. The BMS seems to balance those cells very well. My capacity test did reach full rated capacity of 230 amp hours, and there's still juice left in the battery. I'm very happy with this purchase so far, but if anything changes, I'll be sure to come back and let you know about it. If I had to complain about something, I would say that the state of charge on this little display screen here just took too many clicks to get to it. It took a lot of navigation to get to it. It should be to just push the button and see it right away. But since I have a separate battery monitor installed, I will hardly ever look at that. This battery is pretty heavy at 187 pounds, but that's not a negative. That's just because there's a lot of storage capacity here. Unless I buy some kind of lift or ceiling hoist or something, I will need to have someone help me lift it up on things like this. This battery does have low and high temperature charging protection with 6 separate sensors. I forgot to show you that when I opened it up, but it does have 6 temperature sensors. Also, something I should mention is this battery does have a 200 amp BMS, which is good for most use cases, but if you have any kind of huge inductive loads, you may have to parallel more of these batteries together. Like for 2, you can get to 400 amps, which would cover most everything I can think of. Just to compare it with regular server rack batteries, you know, those are also 100 amp hours each, and they have 100 amp BMS on each one of those, so that would also total 400 amp hours of surge compared to 2 of these. The battery does seem to be very serviceable. I was able to locate those EVE battery cells online, so if one ever does go bad, I should be able to replace it. Currently, this battery is selling for $2,399, which is only 20 cents a watt hour. That is a very good price for such a quality battery with a 10-year warranty. So if you're interested in this battery or any of the other products from Orient Power, you can find a link down in the description below. And that does it for the review of this Orient Power 230 amp hour battery. I hope you enjoyed it, and thanks for watching.